So this video is for the individual test number 4 review part 2. Here are our focus topics again, but these are the ones that we are focusing on today, which are complex numbers, characteristics of quadratic functions, and solving quadratic equations. So first off is simplifying complex numbers, and these are several problems that you guys have attempted before. So go ahead and attempt them on your own, and then I will give you the answers in a second. So I would first start off by writing the numbers from my equation off into the side of my area model. And then I'm going to multiply the values together. And then I'm going to combine like terms and add everything together from the inside of my area model. So we know that the rule that we're going to use today is I squared equals to -1 because we do see an I squared, and I'm going to write that down, and then I'm going to combine like terms and then keep simplifying as much as possible until I get down to my complex number. So I have a real number, which is 46, and then I have an imaginary number, and this is what we call a complex number, and I can stop there. For our next problem is the square root of -32. So I'm going to break this down into 3 pieces. And then I'm going to choose some numbers that makes the most sense. So maybe some numbers I'm going to choose is -1, 2, and 16, because notice what happens when I choose the 16 as one of my numbers. It turns into 4. The -1 turns into an I, and then we have square root of 2 by itself. So some of you guys might have done this a little bit differently and might have done it like this: -1, 4, and the square root of 8. But notice that if you have the square root of 8, that can actually turn into the square root of 4 times the square root of 2. So technically this problem is actually going to look something like this. And these are all being multiplied. So the square root of -1 is an I, the square root of 4 is 2, the square root of another 4 is another 2, and then I can leave that alone. So if I were to actually calculate this out, I'll still have 4I square root of 2. So for the next problem, we have 2I times 7 plus I. So what you would want to do here is, in a problem like this, you guys probably know to distribute this, which will give us 14I and then plus 2I squared. So notice in this problem we have an I squared, so we can change it. So then we'll have 14I plus 2 times -1, and then great. So now we can simplify it even more to give us something like this. So that's our answer for our second one. And then lastly, we have 4 times number 4 is the square root of -50, which I'm going to break down into 3 pieces. And then my best option would probably be 25 times 2, which gives us 5I square root of 2 as our final answer. So moving forward is completing the square. So this is done without drawing the algebra tiles, and see if you guys can figure out what's going on. So I'll just do one with the algebra tiles so you guys can see what the pattern is. So usually if we have a problem like this, we'll have the x squared box right here, and then we have to split up this number in half to give me 6x and 6x. And then on the other side we have a 7. So our goal is to complete the square and make sure that we fill in this missing box, and whatever that is also gets added to the other side. So if you guys notice that I'm using these number sixes, so we know this is 6, this is 6, so in total we have 36 on both sides. So this is 36 and this is 36. So try out the other problems before you see the answers, but the answers are as follows. So we have -7, we divide that in half, so half of -7 should give us -3.5. So even though it's a 0.5, you can still square a decimal number. So that's what I'm going to do in my calculator, and what I end up getting is 12.25, which is going to be added onto the other side. So divide this by 2, we get -4, and if we square -4, that's technically going to give us that number. So notice that this turns into 6. I square 6, and then I square this to get me that. So that's how you do those. So this should be 16, other side should also be 16. So that's how you complete the square without using tiles. Question number 3 is the quadratic formula, and it says that we have A, B, and C to be 6, 5, and 4. What would the quadratic equation in standard form look like? So standard form is y equals ax squared plus bx plus c. So if you know what standard form looks like, all you have to do from there is to fill in the letters. So y equals, my a is 6x squared plus 5x plus 4. And then lastly, we have what would the quadratic formula look like given a, b, and c. So notice that I gave you guys the quadratic formula above, so I'm just going to plug in some values. So I have -5, and then I'm going to put parentheses around it, plus or minus the square root of, and then 5 squared minus 4 times 6 times 4 all over 2 times 6. So hopefully you guys knew how to do that without following my instructions. Next problem is question number 4. It says here are all the steps. Which step is incorrect? So take a look at what needs to be done and where the step went wrong. Okay, so if you haven't noticed that step 2 is actually the incorrect step, and the reason why it's incorrect, because from step 1 we have -4 squared, and if you were to calculate -4 squared, it gave us -16, which is not true, because -4 squared is actually 16, and it does not equal to -16. So that's my reason for that. Question number 5 is to use the quadratic formula to solve for this equation. So again, the formula is above, and then you guys are going to figure out first what your A value, your B value, and your C value. So go ahead and try this problem, see how far you can get. If you get stuck, finish off with the video. So A is 1, B is 5, C is -35, and then I'm going to put all this into my formula. So -5 plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. Okay, simplifying as much as possible, I have -5 plus or minus the square root of 25. -4 times -35 is going to give us 140, and that's all over 2. And then keep simplifying even more. I get -5 plus or minus the square root of 165 over 2, and I believe that's all I can really do. I could simplify 165 down. Let me see if it square roots nicely. I highly doubt it. So 165 does not break down easily, so what I could do is I can actually break down 165. So 165 actually doesn't even go in nicely, because you'll have 5 and then 33, and you can't square root either of those numbers. So I'll just keep it, actually I'll break it apart. So I have one of the answers, and then I have another answer. So one of my answers is -5 plus the square root of 165. over 2, and then negative 5 minus the square root of 165 over 2. And notice that the plus or minus just came from that middle piece right there. So those are my two answers. If you guys want to calculate that down and give me an approximate answer, please do so. All right, question number 6 is the characteristics of a parabola. So we have a few words, which are vertex, line of symmetry, x-intercept, and y-intercept. So the definition follows. So a vertex is the turning point of a parabola. So basically when it goes from either increasing to decreasing or decreasing to increasing. So notice that this is the point where our parabola turns. So our vertex is 0, 2. Line of symmetry is a line that splits the parabola in half. So if I were to stick a line through it, this is the line that will split it directly in half. And it's always denoted by x equals. So x equals, so this is the x-axis. And you'll look at these numbers and see which of those numbers did that line cross. And here we see the number 0. So x equals 0 here. In terms of the x-intercept, it's where our values or our parabola crosses the x-axis, and notice that you guys see 2 points, or you should see 2 points here, which is we have 2, 0, and then we have negative 2, 0. And then lastly is the y-intercept, and then notice that our y-intercept is also our vertex. It's just where it crosses the y-axis right here. So that is our y-intercept. Alright, so last problem is that you guys try to attempt it on your own. Obviously, I'm going to give you some answers towards the end, but go ahead and see if you can get all these answers first. Alright, so our vertex is here, which is 2, 1. That's our turning point. In terms of the line of symmetry, this is the middle, and notice that it always starts off with x equals, so it crosses this value of x. So I have x equals 2. X-intercept, we have 2. We have 3, 0, and then we have 1, 0, and notice the format where 0 is always after the number. However, for our y-intercept, here's our y-intercept, our 0 is before our number, so we have 0, negative 3. So hopefully all of these problems were not too bad. This is our last problem. But flip back and see if you need to review anything, but hopefully all of this is okay. Have a great day, guys.